Hello? Yes, you. Yes, you. I'm looking at you. I'm talking to you. Please, welcome to our booth. And I'm really happy to welcome you to our actually Hyperspectral studio in here. Here, you can see we have our computer working really nicely. Then here we have our demo system with the FX17 camera. And here we have all our other cameras, the FX cameras. I heard that you are here to speak about food. That's wonderful. I have something for you. First, I would like to speak about our company in general. Myself, I am Mathieu. I've been working at Specim for 9 years, and I am now a senior application specialist. We have also our realizator here, who is like Harry, making all those things happening. And we have also Jeff in the United States, in your JZ. Please, Jeff, say hello.
Hello, everyone.
So we decided to make this virtual booth, this virtual studio like this, because of the current situation. Unfortunately, most of the trade fairs, they have been cancelled. So we decided to still be in contact with you. So we mounted this virtual booth here in our lobby at Specim. I will introduce briefly about Specim, our technology, and also at the end of this introduction, I will be really happy to answer to your question or to take your comments. Because there is a gap of about 20 seconds between the time that you see actually what's going on in the studio, I will ask you to write your question or comments during my presentation, and then Harry will give them to me. First, a little story about Specim. Specim has been founded in 1995 by 3 brave riders, we can see it that way, and they are still working at Specim. And since 1995, so we are making hyperspectral imaging. We make it even more easy nowadays. So we decided to develop. We now have an office in US, another one in China. Our headquarters is located in Oulu, in northern Finland, and our CEO is based in Helsinki. We are not a small company. Nowadays, we are about 70 employees for a turnover which is between 13 and 15 million euros. We sold in the past camera mostly for research institute or also universities, but 3-4 years ago, 3 to the best of my memory, we decided to launch our FX cameras. First the FX10, then the FX17. Last year we launched the FX50. Actually, you can see them here. FX17 and FX10 are about the same size. To give you an idea about how big it is, it's a little bit bigger than my hand. For the FX50, it is actually the same size as the A4 page, roughly, to give an idea, and 50 centimeters thick. FX10 is a camera measuring spectrum between 400 and 1000 nanometers. FX17 between 900 and 1700 nanometers. The first one is called VNIR, visible near infrared. The second one is near infrared. The last one, the FX50, which is over here, has been released in May last year. This one is between 2700 and 5300 nanometers. It is a thermal camera and it is mostly dedicated for black plastic sorting. Nothing related with food, but still, because it's part of the family, we decided to invite it on the show. So here it is. So come a bit closer. I will invite you. So here we have a software which is called Perception Studio. This is a software which can classify and sort in real time different type of object, we have different type of spectral signature. Because the idea, if you look at me now, is to understand how a hyperspectral camera is working. At Speaking, we are making line scan device. So for example, if I take this camera, I put it in this position, I will see only through this line. Indeed, inside the camera there is a slit. Also, there is a spectrograph, including prism gratings. And behind here, there is a 2D detector. So basically, the light is entering that way. Then it is deviated. The bands, the light with the highest wavelength is actually getting the longest wavelength is deviated downwards, whereas the one with the shortest ones are deviated upwards. And line after line, like this, is possible to reconstruct a hyperspectral cube. This one is the FX17. For each line, we actually have 640 spatial pixels. You could see it that way. It's like having a line with 640 point spectrometers. With the FX10, here, we have 1024 spatial pixels. With the FX50, we have 640 as well. So now you understood that we are making line scan device with pixels, and each of them having independent spectral information. Line after line, it's therefore possible to reconstruct a hyperspectral cube. Why a cube? When you go on holidays and you take a picture, usually it has only 3 bands: the red, the green, and the blue. With a hyperspectral camera, it's not only 3, but you will have hundreds of bands. So it's not like having a book with only 3 pages, but it's like having a book with a lot of pages, and each page is one image at a certain wavelength. So with the FX10 and the FX17, we have 224 bands, whereas with the FX50, to the best of my memory, it's 168, or close to that number. Those are hyperspectral camera. The good thing with that is that it measures spectrum. You know, when we have people visiting our booth, often they are asking, okay, how does it work? What can you do with that? You know, like every material, every molecule, they absorb or they reflect or they transmit the light at different wavelengths. And when we measure a spectrum, we measure at which wavelengths basically a material or a molecule will actually react to the wavelengths. So each molecule and material, they will have a different way to react to those incoming wavelengths, which is basically the light, and then it will work as a fingerprint. Like everybody have a fingerprint here. That means that also all materials, they have their own. And then by teaching a model, it's possible to identify and to make some recognition of object, to do some sortings. And for example, here, this is exactly what we do on this application. On my scanner, I am actually having some samples. They are almonds, like this, almonds, and the shell. But because the almonds has some oil, but the shell doesn't, it is possible to characterize what is the spectral signature of the oil, and it is therefore possible to separate the shell from the almond. So I put them back on the system. And if we go back to what the computer actually sees, we have been able to teach to the system what was the spectral signature, for instance, of the almond, which is in red, and the one of the shell, which is here in green. You can see here that actually this is not the actual spectral signature, but it is a derivative of it. Derivative of it because then it can highlight different spectral features, different position for the peaks. It can also remove some thresholds which are due to the intensity of the light or due to the brightness. So here, using this as a pre-processing is something which is really relevant. As you can see, I have something called almond and almond dry. We have noticed that when the almond is a bit drier, the spectral signature is slightly different. So because it is slightly different, to make the model more relevant and more robust, we have decided to teach actually two categories of almond. The same for the shell. For the shell, you have the out layer and you have also the inside layer. Because the spectral signature is slightly different, then it was much better to actually have two classes like this. I decided to classify the almond in red, those two ones, and the shell in green. And then it's possible to have the live view again. No. Yes, we have the live view. About the system, about the lab scanner. Here there is the FX17, and as I was explaining, it's measuring actually the spectra over a line. It's important to highlight this part. This part is the illumination. When you are dealing with hyperspectral imaging, it's important to take into account the illumination. When you measure spectrum, you need to have a continuous light. For example, here we measure spectra between 900 and 1700 nanometers. So if you will provide a light which is good between 900 and 1200, then you will have nothing between 1200 and 1400, and again between 1400 and 1700. If there is a gap at the middle, it's impossible to actually measure the continuous spectrum, because how can you measure the reflected light from something if you don't have incoming light? So that's why here, when you are doing hyperspectral imaging, it is fundamental that you are using a continuous light, continuous spectral light somehow. So here we are using halogens. There are some other options available. We know that for food industry, there are some special requirements, especially for frozen food. We are aware that halogens, they are producing some heat. So in that case, it doesn't really matter. But for fish industry, for meat industry, or if you will be dealing for frozen food, heat is an issue, so you may consider some other ones, like LEDs or supercontinuum laser. This is not necessarily something that Speaking can provide, but it's just to give you an idea of the ecosystem. Those exist, and if you go outside of our virtual booth, you can find them. When Speaking decided to develop the FX cameras, FX standing for fast experience, we wanted to have them really usable for the industry. So we made them small, affordable. Unfortunately here I cannot speak about the price because, you know, maybe we have competitors passing by our booth and we don't want to reveal these kind of things, so that's important. So for this type of pricing information, please contact us to our website or our sales managers. So we decided to have small and also affordable camera. And another thing is, like, we were aware that speed matters. And the good thing with the FX10, FX17 and also with the FX50 is that you don't need actually to measure all the bands. If you figure out that you have an application that only some bands are relevant, it's possible to select those bands, making a region of interest. Here the camera could be really, really fast. For instance, if you take the FX10, if you measure the 224 bands, then the maximum frame rate of the camera in the camera link version is about 330 frames per second, understanding 330 lines per second. If you consider that you take only few bands, it can actually be few thousands of lines per second. Of course, to be able to achieve such a fast frame rate, you need to have good illumination, but also good optics. So that's why at Specim, we decided to develop our own optics here, especially the front lens, to have a really low F number. Actually, with those cameras, 3 of them, the F number is 2.0. That means that a lot of light is entering the system, meaning you can have a low integration time. Having a low integration time, you can have a faster frame rate. And if you have a faster frame rate, then you can have a faster conveyor belt. Because yes, you remember, those cameras are line scan device. They can be used like this at the top of a lab scanner, but they can also be used at the top of a conveyor belt. When we are talking about conveyor belt, we are talking about industrial systems. And if we are talking about industrial system, we are talking actually about an ecosystem. And an ecosystem means that you need to have actioners after the sorting is done. So remember, you have the camera here, which is measuring. You have the illumination, and then the signal is transmitted here to the computer. The computer is acquiring the data, processing the data with different type of software. Now I'm presenting Perception Studio from the company Perception Park, but some other software available. For instance, Mira from PerClass, and there is also LuxFlux from LuxFlux. So basically, those software, they can actually translate or interpret the spectra into classes. You remember, I was teaching the system what is a spectral signature of an almond and what is a spectral signature of a shell. So this software has been able to interpret, to transform the spectral information into classes. And then those software, they are able to communicate then with some actioner, with some nozzles, which should be able to blow away, for instance, the shell, or to keep the nuts, depending on the configuration of your system. So this is how it looks like. There is another thing you have to take into account. It is a synchronization. Synchronization between the camera and the conveyor belt. With our FX camera, it's possible to make some external triggering. With TTL pulses, it's possible to send them through the power actually of the camera. For this, we have special cables. So those cameras have been really designed to work on your lab, but also and especially for your production line. Then, an important question is what you can do with those cameras, because you are talking about, I am talking about almond and I'm talking about shells, but it's not everything. You know, it's what I was saying as an introduction. Everything has a different spectral signature. So basically you can characterize. Here, this is what we call a qualitative analysis, sorting A from B. We are sorting shell from almond, but you can see larger. It could actually be sorting contaminant from a good product. So when you are producing good for food, before the packaging is better, because hyperspectral imaging is a surface measurement. So if your packaging is opaque, hyperspectral camera cannot see through. But before the packaging, if you want to be able to detect for quality control, if you have some contaminant, that would be perfect. That could be, for example, detection of stones. It could be the detection of bones in meat, or it could be the detection of fish bones. It could be detection of gloves, different detection of contaminants. But you could also make some quantitative analysis. If, for instance, you want to measure the fat content of meat, this is not contaminant, but you want to measure a property. So hyperspectral camera can do it. For this, you need to build what we call a quantitative model, and then it's possible, after a teaching of the software, to make an estimation of fat content, of moisture, or different type of parameter. It could be also proteins. For instance, for the fruit industry, it could be the Brix, it could be the sugar level, it could be the moisture, it could be the maturity, those things which are more like quantitative than qualitative. And just to give you again a good explanation of how good hyperspectral camera, or how much it can bring you compared to traditional machine vision system based on RGB camera. Take, for example, a chicken breast. A chicken breast is white. The bone is white. The cartilage, again, is white. The RGB camera will not be able to separate them, but the hyperspectral camera will be able to do it because the spectral signature of fillet, bone, and cartilage, and I could also mention the fat, is different. So hyperspectral camera can bring you much more than actually traditional vision system. One thing I would like to highlight again, hyperspectral imaging is a surface measurement, especially when you use it as a reflectance mode. Like here, why reflectance? You have the light which is coming here, going to the sample and reflected, and then the camera can measure it. When you are operating the camera that way, the penetration depth is only few microns, so you cannot really see through. So for instance, if you have some mincemeat and you want to measure the bones or to detect some bones that you will have inside, hyperspectral cannot do it. It will still require, for instance, for X-ray. But if the material is more transparent, you could use the camera in a transmittive way, meaning illumination here, sample here, and my eyes would then be the camera. Then by transmission, it's possible to detect some other parameters. On our system, you can see there is here what we call the white reference. The white reference, it's a Teflon. So basically, it is reflecting the incoming light at a rate of 99% for all the time, for all the wavelengths, I meant. We put it here so that actually the system can be calibrated. You know, when we are making hyperspectral imaging, it is very common we do normalization of the data. So that means that we compare the reflection of the sample compared to the incoming light. This is for the incoming light. You want to tell me that indeed, in an industrial process, I cannot have the white reference like this all the time, standing next to my sample, or I cannot even stop my conveyor belt just to take the white reference. No, you don't have to do it all the time. If you are in a very well stabilized mode that your illumination is pretty constant, you don't have to do it all the time. There is another thing. This is a dark reference. Just briefly, our cameras, the FX camera, include a shutter actually inside. So you don't have to think about having something like to have the camera into a casing with a shutter coming in front of it. No, it's already included in there. And this is to measure actually the dark noise of the camera. We have it. You don't have to do it all the time because those cameras actually they are quite stabilized. Finally, I would like to speak about the connectics. This camera here has a GIGI connection. We also make camera link camera. Because different customers they have different type of requirement, we decided to have actually those two connectors available, those two connectics or interface available for the FX10 and the FX17. With the FX50, only the GIGI connection is available. What I can say as well about FX10 and FX17, the camera link interface is a bit faster and maybe the clock more reliable. Okay, so enough of me talking. It will be good now to hear about your question. I will take a bit of magic potion. And Jeff, do you have any question or do you have any comment about the presentation, about our virtual booth?
Yeah, I'd just like to take a minute, thank Matthew for that great presentation, great introduction to the FX series for industrial food inspection. I'd also like to thank everyone who's joined the webinar, this Q&A session. Normally, we would be out at trade shows and meeting you out in the field, meeting you at your facilities and at trade shows. And these are very unique times. So this is one way that we're using this platform to reach out to you directly. And we already have a bunch of questions that are coming in through the chat function. So we are going to address those. And I hope everyone out there is staying safe, and hopefully we can get back to normal really soon. One question that came in actually before we started the webcast was, Matthew touched on the illumination and how different illumination is required for different applications and in the
Yes.
food industry.
Yes.
What else can you talk about in terms of IP rating for these cameras and the importance of that in industrial settings?
Okay, so first about illumination. About the illumination, here we are talking about halogen illumination, and those one actually they have a continuous spectrum between 400 and 2,500 nanometers. It is really fundamental to have a continuous spectrum. Many people are asking about LEDs. We know that LEDs start to come and start to be available at a reasonable price. The only issue sometimes we have is that the spectrum is not really continuous over the full spectral range, but you may have some variation like this. So if you have some application where you are lucky somehow that the bands that you need, they are exactly where you have those oscillations, where you have those light, then it's really fine. If we can have a look, for example, to our application, the one we are having here. If I go back to the model, we can see that the wavelengths, the band which are the most interesting one here, it's about the band from 46 to 98, or even from 46, let's say, to 150. So if you have an illumination which is quite good between those bands here and here, actually it doesn't matter if you don't have light before or after. The most important is that you are actually having light exactly on those wavelengths. This is the most important. Then we are also aware that, as I was explaining, some of the application they cannot withstand to have halogens mostly because of the heat. So here LEDs or supercontinuum laser could be an option because they don't produce so much heat. So here it's about the illumination. Then you were talking about the IP rating. The IP rating of the FX17 and the FX10 is 5.2, IP52. So basically that means that there could be a little bit of water, but you should not go with a pressure one, with a Karcher or things like this. But still, it's IP52. Another thing to keep in mind, especially for the food industry, we are aware that IP52 is maybe not enough. So IP67 will be needed. And here, actually, we can propose as an option a casing for the FX10, but also for the FX17, a casing with IP rating, a rating of IP of 6.7. So here we can also provide it. Did I answer to the question, Jeff?
Yeah, great. Let's go to some of these other questions we're getting in here live. Hari, do you want to pop a couple of those up on the screen, maybe one at a time?
I did not hear. Hello? Yeah, I can see it. Hello, everyone. I have noticed that the spectral intensity shows peaks on specific wavelengths. Do you focus on those for the classification, or you use all the wavelengths? Okay, so right now, for this, I did not make any region of interest. I decided to build the model with all the wavelengths. But you are correct. There are some bands which bring more information, so we can separate those. As we were discussing before, it was between 46 and 150, the band between 46 and 150. So it is true that I could have reduced my region of interest to those bands only, and actually there would have been some advantages. Speed for the acquisition for the camera, and also less processing power for the software. Okay, here I am making a demonstration with my lab system. I don't want to have the system running too fast, otherwise my almond will run everywhere and it will disturb the people passing by the booth. So I think it's better to keep it like this, but it's correct. It could have been done that way. Any other question?
Yeah, I think there's another question that is somewhat related to that.
Okay, I see there is one like, how can you calculate spectral indices like NDVI or others? Okay, so here we are talking about others application. It could be moisture indexed, it could be soil indices. Basically, the software I have behind Perception Studio is not really made to make some ratio like this to calculate NDVI. But how to do it? So you record all the bands. So basically, when you calculate an NDVI or another index, you just pick up the bands that you're interested with, and then you can process the bands as you want. Here, the model that I am running, it is a PLSDA, partially square discriminant analysis. There are some other approaches. Many of our customers are actually using MATLAB to process their data. And when you are using MATLAB, you can have a bunch of formula, a bunch of mathematical tools that you can use, and then, of course, you can make like different type of NDVI. And those formulas, you can find them on Google.
Yeah, that's also important to note that we are showing here third-party software for analysis, but we also offer the SDK with every camera. So a lot of our customers will produce their own software to do a very specific task. So if you needed to calculate content or look at certain spectral regions and do different model analysis, you can do that in MATLAB, like Mathieu was saying, or other software packages like that. So the next question, in industrial setup, what's the maximum speed of a conveyor belt possible to detect in full band mode? So I guess not looking at that multi-ROI that you were talking about, Mathieu, but the full spectral band.
Okay, so that's an interesting question actually. So we are aware that speed matters, especially when you have a conveyor belt. So think about it. If you have a conveyor belt which is about 50 centimeters as a width, and you put, for instance, the FX10 at the top of it, you can calculate that the pixel size, it is actually the size of your belt, which is about 50 centimeters, divided by the amount of pixels. So in that case, if with the FX10 you have 1024 pixels, that means that actually the size of your pixel will be about 0.5 millimeters. This is the resolution you have like this. Then, if you want to go at a frame rate with a camera at, for instance, 100 frames per second, and you want to keep the same spatial resolution in this direction and this direction, actually the conveyor belt will be able to run at about 5 centimeters per second, which is not fast. But if you have a lot of light and you can put the camera at a maximum frame rate, and also you can reduce the amount of band that you're interested in so that you can even speed up the camera even more. We have seen, for example, in the recycling industry, belt going up to 2 or 3 meters per second. And here we are talking about belt which are, for instance, 1.5, 2 meters wide, and then going at about 2 to 3 meters per second. So it depends on the accuracy you want to have. It depends on your application as well. But as I said, typically we have seen up to 2 meters per second. This is for recycling. For the food industry, we have seen it more often at about 1 meter per second.
Yeah, great. What's our next question?
So what is the focusing grid and what percentage resolution is accepted for image recording? Focusing grid. So you mean how we are making the focus, basically. So how we are making the focus, it's just simple. You take the white reference, or you take a really white object, and then you put a dark object at the top of it. Typically, it could be a lens cap. I was looking where it was. It's under the scanner, so I will not dig there. But so you can put there, and then because you are having a line scan device, you look at something bright, and then you have something dark, hop, it will look at it, your signal will drop. And the transition between bright and dark needs to be as sharp as possible. Then you're asking what percentage resolution accepted for image recorded. I'm not sure to fully understand here what you mean. Jeff, do you have any comment here about percentage resolution accepted for image recording?
It's probably referring to how basically the pixel size of the image spatially resolution of the object, and then I guess moving on the conveyor belt, going frame to frame with line scanning.
So maybe it will mean like how many pixels will be necessary per object to be detected. That could be one thing.
Right.
So we are used to say that the resolution, for resolution, you need to have 2 pixels. This is somehow the full width half maximum. So we don't like to say that the size of the pixel is the actual resolution. So if I have a pixel size which is about 0.5 millimeter, we like to say that the resolution is about 1 millimeter, because it's always good to have 2 pixels to detect an object. I will take the next question.
Yeah, there are a few questions here about detecting specific materials. So we'll get to those next. Let's do this one first. Can you develop and calculate a self-made spectral indices?
Well, you are free to do whatever you want. So basically, you get the data from the camera, and then if you figure out that for fruits or for different type of material, one indices is working better than another one, and it's not published somewhere because not everything can be published, please go ahead. Just play with the data, actually. That's the beauty with it. You can have with hyperspectral camera, that's the good thing, you know, hyperspectral camera is not multispectral camera. Hyperspectral camera, you can have all the bands. So you are free to actually tune your system. What happens if I take those bands, those bands, those bands? If you will have a multispectral camera, you will be fixed. But here you have the full flexibility. So just be crazy, I mean, with the data processing, just do as you want.
Yeah, I think related to that is, you know, what other kinds of materials can we look at? Obviously, we're showing nuts and shells being separated here. There, you talked about contaminants and looking for bone. This is a surface investigation, basically. So there are a few questions on specifics on what we can detect. One is about rotating objects with a line scan camera. Another is for vitamins, micronutrients and vitamins, and another on can we look at the signature of real seeds versus counterfeit seeds. And I guess all of those rolled into your last answer is everything has a spectral signature. So if you have any comments on those specific applications, I guess we'll listen to that.
Well, the thing is that, yes, everything has a hyperspectral signature. Then it's depending on choosing the right camera with a relevant spectral range. I mean, for instance, you don't detect the same thing with an FX17 or with an FX10. If you want to speak about Brix index, of course, you need to go for VNIR for fruits. But if you want to speak about fat content, you need to go for NIR, but not with a VNIR. So this is important. Another thing you have to take into account, of course, is the geometry of what you want to do. We are talking about round objects like apples. Okay, we are using line scan device, so they need to rotate. But sometimes they can be elongated. It could be, for example, like cucumber. Cucumber, they can rotate, but they can also be traveling somehow in a parallel way and working with transmission. So, yeah, of a rotating object with line scan camera instead of an object on the, on the moving stage. Yeah, it's possible, but with a round objects, a rotating object, it might be a bit tricky. You may have to have like a setup where the object is with the camera and then rotating like this and then moving to the next stage. It depends on the industrial setup. And there's the other question, so I need to ask my realizator, can we add actuator by the parameter from Specim? What do you understand, Jeff, by actuator?
Not sure.
Me neither.
Let's go to another question, Rio, if you're still here. If you want to type a clarifying question into the chat box, we'll get to that one next.
Then we have, does the FX17 camera have the ability to connect to mobile device? Oh, well, yeah, actually, to mobile device, it's possible. For instance, now we have launched, not a long time ago, the AFX cameras. And inside the AFX camera, we have the AFX10 and we have the AFX17. And those, they have been developed basically for UAVs, for drones. And inside those AFX, which is a kind of package, there is the FX10 or the FX17 cameras. It's just that there is also the computer, somehow the data acquisition unit, but also the GNSS INU unit to record the position and also the attitude of the platform. But basically the camera is embedded into a moving platform, which is, for instance, a UAV. The camera we have seen also some cameras which has been put in tractors or in kind of translation stage, for example, for greenhouses, where actually the sample is not moving, but the camera is then moving like this. So then the camera is on a moving platform. So yes, it doesn't matter what is moving, if it is the object or if it is the camera, as long as there is a movement. And at Specim, we're actually making some scanners. So you saw the one which is over there, but we are making also with translation stage the plant scanner, where the camera is looking side like this and then moving along the object.
Yeah, and we also have the Specim IQ, the portable hyperspectral camera as well. That's not shown in the background there, but if you have any questions about that, we can answer that offline as well. Oh, Matthew, you might, oh, he has one. There you go. So that's our mobile platform, and that is Wi-Fi enabled. So you can control that camera from a wireless computer. The next question, I guess, is also related to just spectral signatures, right? So how can the black background of the stage be removed from the final sample image? Effectively, you just classify that as background, correct?
Exactly. The background is a class. Actually, if you go back to my application, to my demo here, you can see that there is a class for something called background. So I just decided to have a class for background, so you just recognize the background and then you just classify it as something. Here we have a class for background. Of course, it's in black, so we don't see it here on the Spectral, but it's going to be flat everywhere, because background here, it was like a dark plastic, so basically not reflecting any light, so flat spectrum. But yes, you just need to teach what the background is, and then it's a class and it's recognized, and that's it. It's important, having said that the background has a distinctive spectral signature from what you want to measure. If, for example, you are in the food, you don't have this problem, but if you will be in the recycling industry and the background will be made of the same material of the object you want to detect or sort, that will not work. It needs to be a background, a conveyor belt, which is different from what you classify, and you just use it as a class.
Great. Let's look at the next question. Again, talking about quantitative measurements. So this is really software dependent, I believe. So getting quantitative information, getting the number of pixels effectively of each classification is possible. So Matthew, can you talk a little bit more about how that can be done and if there's a specific software that does a better job than others?
Yeah, so when we are not talking about the question, when you talk about quantitative measuring, could we estimate an exact value, example, bricks number 7, or it's more like between 6 and 8? Well, I must say it mostly depends how you are building your model. You know, hyperspectral cameras, they can be actually really accurate. When you are making quantitative analysis, most of the people, they use one algorithm, which is a PLS, the partial least square. So basically, you have two approaches to do it. Either you have pure component, which is, for instance, for the pharmaceutical industry, you have pure components, A, B, C. And then you teach the system, this is a spectral signature of A, B, and C. Then you can make a model giving a third sample, a D1, and then it will tell you, okay, the D1 is made of how many percentage of A, B, and C. But here you need to have access to pure spectrum. So that means it works really well, for instance, for pharmaceutical industry. But that doesn't work for the Briggs index, neither for the fat content, for instance. So here you need to have a large amount of samples, 20, 30, 50, with known concentration. And here you will tell your model, okay, sample 1 has a Briggs value of something. Sample 2 has a Briggs value of something. And you calibrate your model like this with all those values. And then you are able to build a model which is able to give you a quantitative analysis. And the more you will give samples, calibration samples, the better and the more robust the model actually will be. And you will be able to give some really good quantitative results. One thing about quantitative analysis like this, it's more like an interpolation method. So if you are giving calibration sample which is ranging from, let's say, 0 to 10, and you give something which is 12, it will not be able to find it. I will take another question. Can trace micronutrients like vitamins be quantified using HSI? Yes, some vitamins, they have actually some spectral signature, vitamin, protein, things like this. They have actually some spectral signature, and some of them, yes, can be classified or quantified. Is it possible to get the spectral signature of seed in order to identify the fake seed for yes. Yes, it is possible. Actually, it works as well for the pharmaceutics industry. Some seeds, if they are real, or indeed, if there is a spectral signature, it could be because of the amount of protein which is different, or if there is a coating at the top of it which makes it different. Most of the case, a hyperspectral camera will be able to make the difference. It's just a matter is the difference can be seen. Jeff, you wanted to say something.
Yeah, what wavelength would be the best choice for that? So which camera would be the best choice for
well, I would say
application?
Well, it's application dependent, but most likely I will go for something in the NIR. My big nose is telling me FX17 or even Sphere, but I think FX17 for seeds can be done. Having said that, we are actually selling systems for the seeds industry, not to check if they are real or fake, but to check if they will give a plant or not. But that's another story. Does the camera perform if it is handled with illumination fixed to the camera? Yeah, well, sure, it can be handheld. So, well, here, this is an example. You have the IQ camera. This is a hyperspectral camera, which is between 400 and 1,000 nanometers. You can have your own setup where the camera is in and to have the illumination working with it. So, yeah, it can work. As long as there is a source of light and the light has a continuous spectrum, it can be everything. It can be illumination as you have here on the lab system. It could be handheld. It could be, yeah, as long as you have the light. It doesn't matter.
Sunlight. Even sunlight will work. So,
sunlight, yes.
The other option is also we have fiber connections for fiber optic connection for the FX10 and the FX17. So
Yes.
not necessarily handheld in terms of the camera, but you could certainly have fiber optics hooked up and do it that way.
That's important topics what you are talking about the fiber. I thought about it 5 minutes ago, but it went away, like many things, it went out of my head. So basically now this is again the FX17, better like this. This is the FX17, and now we have a lens. And because we have a lens, we are actually looking with a triangle like this. We are looking with a line. But imagine if you remove the lens, you still have the slit, and this time you have actually fibers which are going somehow to the slit. There might be a relay optics in between, but still somehow to the slit. And then basically the camera doesn't behave like a line scan device, but it behaves like a multi-point spectrometer. And we are happy to say that with the FX17, it's possible to have this type of approach. And it comes to my mind. Sometimes people want to measure things which are difficult to be measured over a line. Think about a cheese. I'm French, but I don't have a cheese with me. Sorry, I don't have it always in my pocket. So imagine this is a cheese. Use your imagination. I'm sure you can. This is a cheese which is thick like this, and you want to image different sides at the same time. It's possible to make a mechanical mount like this and to have actually collection fibers going at different places like this. And then it's possible indeed to monitor at least 3 or 4 sides of the cheese in one click of the camera. So it's possible to do that. With the FX17, now it's possible to put fibers, and the way it has been done, we can have up to 30 fibers, to the best of my knowledge. Is it possible to detect a shard of glass inside a glass jar with white powder? Is it possible to detect a shard of glass, so it means a piece of glass, inside a glass jar with white powder? Well, if it is at the middle, it's going to be difficult. As I was saying, hyperspectral imaging is a surface measurement method. So if you have something located at the middle of a content, it's going to be really tricky. It was almost the same as I was talking about bones inside mincemeat. What are the pros and cons using hyperspectral camera to detect fat content compared to soft X-ray? Okay. The pro is that you don't need to use X-rays by themselves. You need to use only halogen or let's say LED illumination. So you don't have any harmful environment. You don't need to have lead seeded somehow environment. It's not harmful for the body. That's the first thing. And hyperspectral imaging is very, very, very accurate in giving you estimation of the fat content. About X-rays, I'm not myself an expert with X-ray. We have actually a sales manager here who has been working for the X-ray industry, so he will be really glad to give all the details. To the best of my knowledge and what he told me, it's possible to use X-ray nowadays with dual wavelengths somehow to give you more accurate results, but there is still an issue that it's not as accurate.
Yeah, I think it's important to just remember this is a surface study. You're looking at the surface. You can't have much penetration. But I think hyperspectral imaging in conjunction with X-ray detection is very powerful. I think they're very complementary. They can identify different materials, especially if you're looking for foreign object detection. X-ray being very good at detecting bone and material inside, but maybe not the surface plastics that hyperspectral imaging can see. So I think that's important to remember. It's a surface technique. So if you do have uniformity, With your meat content, you can look to see what the general fat content is just by looking at the surface.
Then the next question was how many wavelengths at 10 kilohertz scan rate? Here it depends on the camera. So if I take, for example, the FX10, I took the brochure because I don't know those numbers by heart. But with the FX10, 10 kilohertz, basically it's only one band. So it's not that many, it's one. If you want to go with the FX17, I don't have it exactly for 10 kilohertz. I know for 15 kilohertz it is 4 bands, so I could imagine it could be about 10, something like this, but it needs to be checked. But it gives an idea, I mean. Is your SDK limited to Windows or are other platforms supported as well? The Specim SDK itself, it is Windows supported. Having said that, if you are asking, it's because you are interested in using most likely the camera with Linux. There are possibilities. For example, if you are using the camera link camera, you can use a grabber which is compatible with Linux. For example, Epix, they are making grabber compatible with Linux, and our cameras, the FX camera, are compatible with some Epix grabber. Also, if you are using the Gigi interface, our SDK is actually based on the eBoost Pleora SDK, and this one is compatible with Linux. Another approach will be working directly with the ASCII code, ASCII command for the camera, where you can access the key parameter of the camera like frame rate, integration time, and then you can do what you want with the camera. How to segment the defect from a fruit and classify it afterwards? Well, then it depends on the processing platform you are using. Some software, they give you more freedom to isolate something and then to point it up, or this is more a processing platform. As I say, our customers are working with MATLAB, they are working as well with Perception Studio, Mira, LuxFlux. So those softwares they have been designed to detect defects, so that's easy to do.
Yeah, you can certainly collect the data and then do something with it later almost. You don't have to have an immediate response to the data. I think that's another part of what you're asking there. You can certainly store the data and then do something with it later.
Okay, so how much time taken to process and classify the collected hyperspectral data, assuming full spectral mode, or assuming the data is around 1 gigabit? Okay, it depends. If you are talking about real time, it depends on the algorithm you are using. If you are talking about real time, you can see here I was processing data in real time with my laptop, which is far away of being an industrial computer. So if you have an industrial computer with fast and good processing power, you can really, as I say, process image of about at a frame rate of 2 meters per second. It can be done in real time, it's not a problem. We are talking about milliseconds. Then if you are talking about an image of 1 gigabits, it means that you want to make the processing offline. Then it depends basically on what you do. It depends on the processing you want to do. If it is a really simple one, or if it is a really demanding one. It depends as well on your computer. With the laptop that I am having, 1 gigabit principal component analysis, it takes 10 seconds, 15 seconds. Could you mention surfaces that are transparent enough to look through? For example, when looking at an apple, do we need to measure from all sides? Surfaces which are transparent enough to look through. It could be, for example, a plastic packaging material. Most of them, they are quite transparent. For example, when you have a meat tube, it is in this type of transparent plastics, then it's rather transparent between 900 and 1700 nanometers. When you are talking, for example, for an apple, and you want to see from all sides, it's possible to make an apple glow, for example. If you put the illumination pretty intense at the bottom, the apple can glow. So basically, you don't see through, but you can see some parameter from the inside because of the glowing.
Yeah, and it's important to remember transparent being not necessarily transparent to your human eye, but transparent to the camera itself. That's really important to remember, that if you're using an FX17, for example, you're in the near infrared, you're not going to be able to see that, but the camera itself is transparent, so it may be actually able to look through that material to an object behind it.
So next question, is it possible to use Python? Yes, many of our customers does.
Great answer.
Yeah. Is it possible to mount the camera inside an optical box with a glass viewing windows? Yes, actually, many of our customers, when they want to make their own casing around the camera, for instance, for the recycling industry or for the food industry, if they don't want to use the one we can provide as an option, it's possible to have a box and inside to have a glass in front of it. It's not a problem as long as the glass is transparent enough for the wavelengths you're interested at. Can you detect glass foreign bodies? If they are located at the top of the sample and the spectral signature is different from the sample itself, yes. Actually, our camera can also be used for glass sorting application for the recycling industry. Do we have another question? Yes. My director is telling me yes, another one is coming.
Yes. So my only concern using the HSI system is that the detection of micronutrients, the spectral signature is usually dominated by water. So do we have any comments on detecting nutrients in the presence of water?
That depends. For example, if you are interested, for example, micronutrient, could it be via vitamins, for example, or proteins? It could be, for example, in powder. It could be in powder milk, for example, that you can produce for baby. It could be as well chocolate powder. If you have something like a fruit, this is true that water is quite dominating at the FX17, I mean for the NIR spectrum. If you are using the sphere camera, you can see some inflection in the spectrum, but it depends on what you are talking about. Yeah, if you have a wet sample, that can be an issue, but you can also do for the dry ones. Do we need to calibrate the sensor depending different illumination system? Oh yes. I mean, if you are making the normalization and you measure the white reference with a certain illumination, and for some reason you change the illumination, yes, you may have to recalibrate your model. Having said that, when I did the model, I did it in our demo lab where I had only those illuminations, those halogen on. Then now I am making actually this virtual booth with some LEDs around me, and the model is still performing really well. So yes, if you change your illumination, of course it's better that you recalibrate your model depending on the illumination. Having said that, it depends how accurate, how robust your model is. There is be some.
Matthew, what is the illumination source for the FX50?
Oh, for the FX50, that's another story. I was explaining it's a thermal camera, and then you need to have not halogens, neither LEDs. A good one will be an electrical resistor. It looks like a bit an electrical barbecue, and it is heated up 650 Celsius, 900 Celsius, and this is actually providing the illumination. So this is a thermal camera. It's colder than halogen, but somehow you feel that it's warm because you can access it like a barbecue, but at the end it's a bit colder than a halogen actually. What frame rate can be achieved by the FX10 if only 4 wavelengths are required? I take again the data sheet. It doesn't say it here, or I have to say if it is 10,000 for one band, 4 might be few thousands. Hard to say right now. I don't have it by heart. I don't have it in front of me, but I would say maybe 4,000 or 5,000, something like this frames per second. I would like to use the camera in an outdoor environment. Is it overkill to use halogen lighting? Will it improve my results? Okay. If you are outside, of course, you need to use the sun. And the sun is a great source of light. Having said that, there is something between the sun and you. This is the atmosphere. And there might be clouds as well. So if you are using the FX10, which measures the spectra, the FX10 or the IQ camera, by the way. So if you measure the spectra between 400 and 1000 nanometers, the sun will provide a really, really good illumination. If you have a cloud, then you know it's water, it will absorb the light will be less intense. So basically, you will have a low signals in the NIR part of the spectrum. So then it might be relevant if you want to still have a good signal to use halogen. The same applies for the FX17. If you have a clear sky, you will have a good signal, except when you have the atmospheric absorption bands, which correspond mostly to the water and oxygen for this spectral range. So here, if you really want to have a good signal everywhere, then you may want to use halogen to compensate. But otherwise, the sun is a really good source of light. Does Specim IQ have a slit inside? How does it work without moving it to the capture hyperspectral cube? How long does it need to take a hyperspectral image? Yes, the Specim IQ, which is over here, again, has indeed a slit which is inside. It has a slit, but the beauty with it is that actually the scanner is inside the camera. So basically, there is a lens which is giving a square image, and then the slit plus the optical part, the spectrograph and the detector is moving like this behind the lens, so that actually you reconstruct the image the same way as you do with the FX10 and the FX17. And line after line like this, you still reconstruct your hyperspectral cube. Then you were asking how long it takes to take an image. Usually when I am out, you said, I was wondering if you were asking inside or outside. If I am outside a summer day, clear sky, I would say it takes about 10 seconds. But if it is not that clear or it's a bit later in the day, it can be up to 3 minutes. So it mostly depends on the illumination.
Yeah, if you're inside and you have bright halogens, it is a minimum of 1 millisecond exposure per line. So when you add that up in terms of 512 lines and the time it takes to scan, it's about 3 seconds, 5 seconds for one full scan.
Is it possible to detect the presence of only 10% silicone in water? Do you have experience, for example, a lubricant that we must guarantee the presence of this silicone? No, I don't have experience. Sorry. I haven't tested everything. Silicone, this is true, has good absorption in the VNIR. That's why actually CMOS, FX10 is based on a CMOS detector. It's a silicone because we know it absorbs really well in the VNIR spectral range. No, I don't know. Potentially it can work, but I haven't tested and it needs to be tested. I prefer to say I don't know. There is a potential, but I cannot warranty.
Yeah, I think that's a good time to note that we do experiments. We can do feasibility studies. So if you do have a particular application that you're interested in, like this one that we may not have information on, there may be opportunities for us to run some samples and to find the answer. So that's an important thing to note.
Then there is the next question. Can we calibrate multiple cameras units of one data set acquired from initial sampling, taking into account the same camera illumination is used? Yes, you can do that. Yes, you can do that. And the good thing with all the FX camera, FX10 and FX17 separate and also FX50, they all actually have the same spectral calibration as an output. So if you acquire a data set, a calibration data set, you build a model which correspond to some wavelengths. Actually, the beauty with the FX camera is that all of them per family, they give you the same output. We have this image enhanced correction. I'm using the right term, I think. Image enhanced correction, which is embedded inside the camera, so that actually they are somehow hot swappable for this type of application.
Yeah, another question, the maximum focal length and field of view of the cameras, and that's going to depend on the size of the sensor. It's also going to depend on the optics, right? So we have different input lenses that will give you different fields of views.
Okay, so basically I will answer to this question, but we will have to finish actually our session. About this one, maximum focal length, field of view. Now I was showing those FX10 and 17, especially the FX17 there with a field of view of 38 degrees. There are several options available. With the FX50 we have 3 options, 24, 60 and 45 degrees. We have several options. I got instruction from our realizator that we need to go. So actually the virtual studio is telling us we need to shut down. So basically, thank you for joining. You can still reach us via those email address. Jeffrey, you saw him in US, me, myself in Oulu, Spekim. You can also send your question or request in info@spekim.fi. We will be able to come to you. Again, thank you very much for joining this virtual booth. I wish you a nice evening. Bye. See you at the next trade fair in Rio.